Chapter 14.2 is finding the partial derivative. It has a little bit different notations than what you have seen so far. It has an f with a little subtext x here, and then x comma y. So that's one type of partial derivative. This is taking the partial derivative with respect to x. So we will treat x as the variable and y as a constant. So it's like a totally different concept, right? We also want to find f with subtext of y, x comma y. This is partial derivative of y. We are going to partial derivative with respect to y. We're going to treat y as a variable, but x as constant. That sounds different, huh? So we are taking partial derivative with respect to x, and what that means is we're going to treat x as a variable and treat y as a constant. Is that okay? All right. If it looks like that, which we see this time, subscripts have y there, right? So this means we are taking partial derivative of what? With respect to y, which means we are treating which one as variable? Which one? Y as a variable, and then treat x as a constant. So how would that work? I'm going to give you a function. The functions, this time the function have both x and y, and the function have 9x cubed plus 4x squared y plus 13y squared. The first thing we are going to do is going to be doing the function taking partial derivative with respect to x, which we say treat x as variable, treat y as constant. Keep in mind we are taking derivative, right? If we have, we are keeping in mind we are treating this as the variable, this as the variable, the other one are constant. So this would be the same as what we regularly do, right? If we're taking the derivative of 9x cubed, then it will turn into what? 27. 9 times 3 is 27. X go down 1 degree, right? Everybody okay? If 4 and y are both constants, then it will do what? But it's multiplied to x squared. So if it's just 4x squared, you do what? 4 times 2x, right? But this 4y is constant. So instead of just 4, you will have, hold on. If it's 4x squared, you say 4 times 2x, right? If it's just 4x, you will have 4 times 2x, right? Because 4 is a constant, right? But if y is also a constant, then you do what? It means 4y above here, because this and this are constant, so they just stick with it. And then when you take the derivative of this, is 2x. Is it okay? It's going to take some practice. Both 4 and y are constant in this situation, so just 2x, okay? This one, no x, right? So the whole thing is constant. Then it will become what? 0. So this is the 2x here. Are we okay? So kind of weird, right? It's going to be 27x squared plus what? This is 8xy. So this is taking partial derivative with respect to x. So you treat y as constant. So let's do the other way around. So I'm going to write this function one more time. The function have both x and y. It was 9x cubed plus 4x squared y plus 13y squared. Okay. This time we are going to have focus on this is my variable, but the x is constant because we are doing f with subscript of y here, x comma y, meaning we are taking partial derivative of this function with respect to y, which treat y as a variable but x as constant. X is constant, right? Meaning this whole thing is constant. It will turn into 0 here. Everybody okay? Both this number and x are constant, so this whole thing is 0. Okay, so now y is variable, but 4x squared is constant. So when you take the derivative of y, this will turn into just 1, but this is constant, right? So it's going to be just write down what you have, or bring it down 4x, but the y will become 1. Is it okay? Square, sorry. No, it does not go away. Okay, sorry. It's 4x squared because both 4 and x squared are constant, right? So we just write it down, but taking the derivative of y would be 1. Okay, now again, y squared is my variable, right? So we have 13, and take the derivative of that part will give me 2y. This is going to be partial derivative of y, x comma y will be just 4x squared plus 26y. Are we okay? This is the basic of it. I just want to show you one example. I'm going to show you more next time, but I want you to have the basic idea. This is treating x as variable, y as constant. This is treating y as variable, x as constant.